Assalamu alaikum. Hey guys, this is Ahmed Al-Hallak, and these are the solutions for the first lab quiz, which was based on Flowgorithm. If you remember, I believe that you have taken this quiz like maybe 2 weeks ago now, or maybe 1 week ago. I promised you that I will make a video to show you the solutions for all the questions. I believe there were like 10 questions in that quiz, and 4 of them were related to the first lab. And the questions were random, so you had 4 questions out of these questions, and you wouldn't have the same questions as your friends. So bottom line is that I'm going to solve all of these questions for you. This document has a total of 19 questions, right? So we are going to go through all of them as fast as possible. Now let's start. Here is saying using the information, using a blank information can be displayed. It's basically the output box. All right, that's really easy. A blank is a Flowgorithm data type that contains a sequence of characters. This data type is basically the string, because a float is a numeric data type, integer numeric data type, boolean which is 0 false or 1 is true. Okay, and let's take the other options in this example. Here you have, for displaying information to the screen, it's the output box or the output function. The declare box is just to declare variables, and this is used at the start of each program in Flowgorithm and any statically typed language. Right? The input box is used to take an input from the user or to read a value from the user. And the for loop is a for loop is not used for displaying anything. It's just a loop that you can do whatever you want inside of it. If you want to display stuff inside of it, basically you're gonna need an output box to display this information. Okay, so this is just for iterative execution. Now let's continue. Consider a variable age that's assigned a certain value. Which of the following string concatenation methods are wrong in Flowgorithm? Basically, in Flowgorithm, when you want to concatenate something like I have like 23 years old, so this means you're concatenating if you are using 23 in a variable like the age variable in this case. So you have like 3 segments that you're going to concatenate. The first segment is a string, the second segment is a variable, and starting from the second part after the first string, you will need an ampersand, which is the concatenation operator. And for the third segment, which is the continuation of the phrase years old, you will need another ampersand or concatenation operator. Okay, so this is correct. All right, and let's go for the next one. The second segment needs an ampersand. The third one should have an ampersand here, so this is basically wrong. And the third one is basically you don't concatenate like this in Flowgorithm. All right, you will need I have close double quotation, and before the age you will need an ampersand, and before the new string or the third segment you will need another ampersand. So A or let's say B and C are wrong. Okay, the only one correct here is A. Okay, so it's C and B. Right? Arithmetic expressions enclosed n are evaluated first. Enclosed n, basically parentheses. Curly braces, this is curly braces. Okay, and basically curly braces aren't really involved in arithmetic expressions. All right, and parentheses, anything between parentheses like this are basically evaluated first. Square brackets, we are going to introduce square brackets to you at the very last lab, the 5th lab, right, when we are going to talk about arrays and vectors. So it's not really used in arithmetic expressions. Angle brackets, these are angle brackets, right? These are basically, there isn't actually a use for angle brackets in Octave rather than the logical comparisons. Like you can use comparison operators like this, like this. That is the only use of angle brackets in Octave. Okay, double quotation is basically to wrap anything between double quotation. It's just you saying that this is a string. Okay, so this still not used in arithmetic expressions. Alright, so it's basically the parentheses. Now the forward slash, which is this character here, you will find this character I think it's, yeah, beside your shift button. This is called the division operator. Okay, this escape sequence and escape character, I'm just messing with you guys because these are they are in C, right? They're basically in C, and they are in Octave too, but I just don't want to mention what are the escape sequence and what are the escape characters, because I think they are a little bit out of scope. Okay, but bottom line is this forward slash is the division operator. Okay, all right, evaluate the following expression. Basically you're gonna start with the operator that has the highest order of precedence. So basically we have multiplication and division, they are of the same level of precedence, so we're going to evaluate whoever comes first. So let's take these two operands, 3 and 6, and evaluate this to 18. Divide 18 by 2 is going to give you 9. Alright, then 9 plus 7 is going to give you 16, minus 1 is going to give you 15. Stored in the variable result. Basically, if you try to sum this expression to a number, then this is totally wrong. If you said something like, yeah, 3 and 4 is 7 with 1.5, this makes it 8.5, this is wrong. I'm putting these expressions, or putting this expression between double quotation. I'm just messing with you. Anything inside double quotation, this is not going to be evaluated. This is not a mathematical expression anymore. This is just considered a bunch of text between double quotations. So this is a string. So whatever is going to be stored in the result variable is the same exact form that is between these double quotation. Okay, so 3 plus 1.5 plus 4, this is the same thing that's going to be stored in the result variable. Okay, because that's a string, and whatever you write in the string between these double quotation is going to be. Alright, let's continue. What is the output of the following program? Okay, someone will say that, alright, I know that if I just had time in that quiz, I would have just opened Flowgorithm like real fast and tried to do the following program in Flowgorithm, and I will run it and see the output. Well, if you had time, you would do this, but this is not to test how fast you are in writing programs in Flowgorithm. This quiz is just to test what is your understanding level of Flowgorithm, or of programming language, of programming concepts in general, right? And it's also to test how good are you in tracing code. And by tracing code, I mean looking by your eye at the program like that and just figuring stuff out and writing whatever output that you think it will be outputted from this program on paper. Okay, let's try how can we do this. I'm just gonna take a screenshot and I'm going to go to my dashboard, whiteboard here. Okay, this is our guy. Let's just, alright, so let's trace this program. Let's see. Now you have a variable in memory. This is your memory, okay? You have a variable called x and you have a variable called y, and both stores integers. It is said that y is starting with an initial value of -1, so you're just going to start with y like that. Then you'll go to the third step. Okay, we have done the first two lines. All right, so now we are in the third line, or the third block, which is your for loop block. Okay, so the for loop is saying that you will have like from 1 to 5 iterations with a step of 2. So you will have x is gonna be, for the first iteration, it's going to be 1 with a step of 2. Then you will have x equal to 3 with a step of 2. You will have x equal to 5. Okay, so you have total of how many iterations? 3 iterations. Okay, all right. Now in the first iteration, this is our first iteration, x is gonna be equal to 1. So let's set x to 1 in memory. Okay, he's saying that for the first iteration where x equals 1, if y, this is an if block, so if y is greater than or equal to 2, if this is true, I'm going to output, this is your screen, remember, okay? This is your screen. Okay, so if y is true, if y is greater than or equal to 2, we're gonna output y. But if you look closely, y is -1. So basically, this is false, right? So if it's false, it's not gonna do anything. Then after the if statement finishes, it's gonna execute this block, all right? So this is basically saying that y plus 1. So we evaluating the right hand side first. And y from memory is -1 plus 1, so you have a total of 0, which is going to be stored in y. So the new value of y is basically 0. So when this line finishes, we will go back to the head of the loop. Remember, the program is now stuck inside this for loop. Alright, so we will be coming back to the head of the loop, and we will increment the x. Remember, x was 1. When we go back to the head of the loop, we will say that we will increment x by 2. So basically, x is now equal to 3 when we increment it by 2. So this is x. We are in the second iteration. And before we enter the body of the loop, which is basically this area, before we enter inside the loop, there is some kind of a check that happens inside this head of the loop. It says now x, after you increment it, x equals 3. So we're gonna update x in memory, and we're gonna say, is x less than or equal your end value? Basically, our end value, if you remember, is 5. This is the end value. Okay, so there is some kind of a check that is happening within this head of the loop before you embark in going inside the loop and executing whatever is inside. Okay, so after you increment the step of your counter, we incremented our counter, which is x, with a step of 2, so it became now from 1 to 3. We made this kind of a check inside. This is made like automatically. It is said that this condition is checked like this. After you increment it, is x less than or equal your end value, which is 5? If this is the case, this is true. If this is true, then jump inside your for loop and execute the following body of the loop, which is this area, one more time. So this is true. So we will be going inside this for loop one more time, and we will be executing this one more time. Okay, and now I'm just going to just going to delete these guys because we are going to execute all of this again. Okay, so basically this condition is true in the second iteration, so we're going to enter the loop with an x that is equal to 3. Just remember the counter, remember the number of the counter. Okay, so x now is equal to 3. We have updated this in memory. Now let's say, here's saying if y is greater than or equal to 2, and you're going to check the value of y, and you're going to see that y previously, in the previous iteration where x was 1, we have just incremented y by 1 in this final step in the previous loop, or the previous iteration, and y is now equal to 0. So basically 0 is not greater than or equal to 2, so this is false. So this if statement is going to be skipped because nothing really happens in this false path. So we're gonna go to this point where it really declares the end of the if statement, and we're gonna go to this block and execute it. Okay, so this block is saying whatever on the right hand side is going to be evaluated and placed on the variable on the left hand side. So here we have y 0 and we have 1, okay, plus 0. This is going to result in 1. So the new value of y is going to be 1. Okay, so I'm not going to exit the for loop. Remember this. This is really important. You need to understand how the for loop works, or how does generally any loop works. Okay, so we're going to go back to the head of the loop and check. First you will increment. Okay, so you will go to the head of the loop, increment x, incremented by 2, so x now is equal to 5. After the increment happened, within the head of the loop, a condition will be checked, this condition will say something like this. Now x in the third iteration is equal to 5. We're going to update x in memory to be 5. Now we're going to say if x is less than or equal to the end value, which is 5, and this is definitely true. It is equal to 5. So if this is equal to the end value or less than the end value, we will jump to the body of the loop. We will just go straight ahead and execute whatever is inside this for loop. Okay? So now x is 5, which is considered equal to the end value here. So basically we were going to execute whatever inside this loop. Alright? So I'm going to the if statement first, and I'm going to see, is y is greater than or equal to 2? Okay, let's see. Previously, in the previous loop, we have incremented y one more time, so y is now equal to 1. 1 is not greater than or equal to 2, then this is still false. So I'm going to skip this if statement because nothing really happens in this area, right? And I'm going to go to this block right there. And I'm going to say y, which is now equal to 1 plus 1 inside this y, so the new y is 2. Alright? Then I'm going to go to the for loop. Alright? Now, increment the for loop. Alright? When you increment the x counter is gonna be 7. Alright? Now you're gonna check in the head of the loop after you increment. Is 7 less than or equal to the end value which you have set up here, which is 5? This is definitely false. So if this is false, you're not going to go inside the loop. You're not going to go inside the loop. You're not going to execute this area anymore. You're just going to skip the loop. You're going to go out of the loop and like execute whatever beneath this for loop, right? So basically, what's going to print it is nothing. You will not see any output in your screen, okay? But just check the answer just to show you that nothing will be displayed, okay? This is the answer, right? But if you had your end value 7, if you had it like 7, okay, what will be displayed is definitely y is going to be 2, and you're going, if this is 7, if x is 7, then basically x is less than or equal to 7. Yeah, it is equal to 7. This is going to be true. Then you're going to go inside the for loop body here and execute this body of the loop, and you're going to say, now does the y is larger or equal to 2, and you're going to check the previous or the latest value of y, which was 2, and you're going to say, yeah, 2 is equal to 2. Then you're going to output y. So if you had the for loop condition from 1 to 7 with a step of 2, then this program would output the result of 2 to your screen. There is going to be 2 to your screen. But because I had my for loop ending at 5, then we didn't see anything to the screen. Nothing was displayed. Right? I hope this is clear. This is the kind of tracing that you need to do it by hand. Alright? Now let's continue. I believe this was the hardest question of them all, right? Now, we wish to write a program that detects the number 10, okay? The program should first check if the entered number is positive or negative. If the number read is positive, it checks whether it equals 10 or not. If it is negative, it should only tell the user it is negative. What can be modified to achieve the previously mentioned functionality in the following program, right? So he's saying here that first of all, this program detects if the number is positive or negative. If the number entered is positive, it's gonna check if it is 10, exactly 10 or not. So if it was exactly 10, it's gonna tell you that it's a 10. If it's not, it's just gonna say it's not a 10. So we have these options here: initialize y with a specific value at the start, and declare an extra variable. Let's just do it in Flowgorithm real quick. just so you can understand what's going on. Gonna declare the y, we're gonna input the y, and we're gonna say if y is greater than 0, we would say a positive number. We first detect if the number is positive or negative, okay? And if not, or if else, we would say a negative number, right? Then I'm just imitating what this program is doing, right? So I'm going to add another if statement, and let's say if the number entered was exactly 10, I'm going to say and it's a 10, okay? If it's not 10, I'm gonna say but it is not a 10. Alright, so let's run this and enter something positive. Let's enter something positive like 2. It's gonna tell you it's a positive number, but it's not a 10. Now let's run this one more time and enter exactly 10. It's gonna tell you a positive and it's a 10. Let's enter a negative number this time. It's gonna tell you a negative number. Alright, but the thing is, I just need to know that it's a negative number. I'm not really fond of seeing this sentence at the end. I don't want to see, but it is not a 10. This is not supposed to show up because it's a negative number. The only case that I want to see a follow-up sentence like that, if the number was already positive, whether it's positive and it's a 10 or whether it's positive and it's not a 10, I want to see a follow-up statement like this. But if I entered from the start a negative number, why do I need to see this statement at the first place? Yeah, so this is the idea of the question. He's telling you what can you modify to achieve this functionality. If the number is positive, it checks whether it equals 10 or not. If it is negative, it should only tell that the number is negative. It shouldn't tell you that it's a 10 or it's not a 10. Okay, that's the idea. So basically, what can be done in this case? You don't really need two if statements. You don't need like sequentially two if statements. You can take this if statement and nest it in this path where you have checked that the number is already positive, okay, and just add it there. Yeah, that's the only solution here. So basically, if you have entered something that is positive, this first path is gonna be checked. If it's positive, it's gonna check, does this number that you have entered is equal to 10? If it's 10, it's gonna tell you that it's a 10. If it's not, it's gonna tell you that this is not a 10. All right? Now enter a 10, it's gonna tell you that's a 10. But from the start, if you have entered something negative, it's just gonna tell you that's a negative number. You don't need this follow-up statement, where is it saying that it's 10 or not, it's not a 10. Yeah. So that was the initial idea of this program. Okay. So the idea here, or the answer, is to nest the second if in the right path, which is the true path, like nested it, just the way I did it here. Okay. The following program may contain an error or more. Which of the following statements solve these errors? First of all, let's determine the errors here. Now you have said that y is of type string, so you can assign strings to y, and message is also of type strings, so you can only assign strings to message variable. Okay, now you're saying that y is accepting or assigned to it 3.5, which is a numeric value, and this is completely wrong. And you, based on this wrong decision or wrong assignment that you have said, you are trying to make an if statement based on this assignment. You're saying if y is greater than or equal, and this statement is wrong. When we say greater than or equal, we flip these symbols. The greater than comes first, then to the right of it you write the equal sign. Okay, so this is the second problem in this code. Okay, so you're saying just go along with this and let's say that this comparison is true. He's saying if y is greater than or equal to 3, he's gonna say message is greater than or equal to 3. Right? You can tell that message usage in this program is correct. Message is of type string, and he is assigning a string to message, so this is acceptable. Okay, and by the end of the day he's trying to output message. But remember something, if you outputted message between double quotation, this message, this string, this text which is greater than or equal to 3 will not be printed. Why? Because you're trying to output message between double quotation. And remember, I told you, if you wrapped anything between double quotation, whatever inside the double quotation will be printed. So in this case, if this is true, none of this text will be printed. The only thing that's going to be printed is the word MSG, message. Okay, so this is not an error, that's not an error, but that's just a faulty usage for whatever he has done in this program. Okay, let's check the false path. In this false path, he's saying message equal less than 3, and this is a string, and any string needs to be wrapped between double quotations. So this is an error, because he's trying to like store a string that is not even representing the string data type, because it's not wrapped in double quotation. So this is gonna give you an error. Okay, by the end of the day he's trying to output message, and outputting message like this is correct, and this is also systematically acceptable. There's no errors at these two lines, output message or output message between double quotation. The errors here and there and here. All right, so he's saying, I know that this problem might have, like, it needs a little bit reading. So he's saying at the assignment of the variable y, 3.5 should have been wrapped in double quotation. Right, he's saying if you have an error, check which statement should solve these errors. So basically, if you wrapped this 3.5 assignment between double quotation, this would solve this error, because now you are assigning an actual string, like double quotation here, 3.5, and close the double quotation. So you're assigning a string to y, and that's acceptable, because you declared y as a string. But that's not gonna actually help you a lot with the following blocks, because if you check the block after it or beneath of it, you're gonna say that he's trying to compare y to a number, and y is a string. You can't compare strings to numeric data types. So this A option, it actually solves this first problem in this block or in this line, but it actually wouldn't really be useful for you in the second block, which is the if statement, because you can't compare a string to a number. So that is a temporary solution at the second line or at the second block, but it's not going to be helpful for you on the long run in this program of yours. Okay, so let's check B. He's saying when the if condition is true, the output will be message. The double quotation around message should be removed. Well, this is like logically correct. That doesn't mean that there is an error here. Okay, I told you that if you try to output message between double quotation, it's gonna output message. But that doesn't mean that this is an error. It's just a faulty behavior. The developer does not know that this will happen. But that does not necessarily mean that this is an error. Okay, that's a faulty usage. That's it. So if you remove the double quotation, the message is going to be printed, which is in this case greater than or equal to 3 is going to be printed. That's correct. But that does not resolve the error in this area or in this area. Okay, so let's see C. At the assignment to the left of the if statement, the assignment to the left, which is the false path, the expression less than 3 should be wrapped in double quotation. That's correct. This is gonna be definitely an error, because this is an unknown data type. Okay, the data types that Flowgorithm understands is data strings, numeric values, which are integers, real, boolean. This is none of them. So we need to make this one of them by just wrapping double quotation around this text. So this is now a string. So C is correct. C actually solves something. A solves something, but for a short period. When you go to the second block, you will find that the solution or the salvation that you have chosen in A does not really help you a lot there. Okay, so let's go to Z. Inside the if box, greater than or equal should be written like this, and that's completely true. Comparison operators always are written like this. All right, This form here, this is not correct. So C and D are correct so far. Okay, the variable y should be changed either to real or integer, and this is better than the A suggestion. What has been suggested in A is that 3.5 is because y is a string, so basically you need to assign a string into y. So A was saying that you can wrap this 3.5 in between double quotation, but this will be problematic when you reach this line or this if statement condition block. So instead of them, E is suggesting that from the start change the data type of y to be a real or integer in order for this to be acceptable and in order for this comparison to work, because now we're comparing a number to another number, and this is how comparison is done, like data types that are similar. Right? So basically we have C, D, and E. These are the correct answers. Okay. Now let's see. The following is a valid assignment statement. By the first look of this is not a valid assignment statement, because if you are evaluating something, whether it was addition, subtraction, multiplication, evaluating the expression happens on the right hand side, and the variable should be on the left hand side. So this should have been written like this. Okay, this is the true form. Okay, evaluating the expression or the mathematical expression happens on the right hand side, then whatever on the right hand side gets assigned to the variable on the left hand side. Okay, but this form is not correct, so this is not a valid assignment statement. False. The following is a valid output statement. Let's see. Output, the summation result is concatenation operator 1 plus 2, and this is gonna return 3. That's totally fine. Try it in Flowgorithm. It's totally fine. Okay, all of the following variable names are valid. Okay, num1 is correct. Age is correct. First number, it has like, let's just remove this error. There's an underscore there, so it's correct. Second number, that at some no, that's not correct. You cannot name a variable like this. It's gonna give you errors. Let's try to name a variable called comma if name, like first name with a dash like this. It's gonna tell you that identifiers, or meaning variable names, must start with a letter followed by a series of numbers. So this is not an acceptable syntax, or is not an acceptable naming convention for variables. So this is wrong. My name, you can't just declare a variable and have white space between the name, between any of the characters in these variables. This is considered to be a variable, and this is considered to be a variable. That's why this whole thing is wrong. Okay, this is acceptable. If you want to start your variable with a number, that's acceptable. Let's try this. 2D, for example. Okay, now let's go to this guy here. You can't start a variable name with a number, and you can't start a variable name with a symbol or a character like this. Okay, so this is wrong and this is wrong, but this is correct. That's normal. You can start with a letter, then follow up with any number you like or any character you like. Right? So are all of them valid? No, not all of them. This is wrong, and this is wrong, and this is wrong, and this is wrong. 4 of them are wrong. Okay, the first 3 are only acceptable. The arithmetic, times, division, plus, subtraction, all of them have the same level of precedence. That's not correct. That's still not correct. There is an order of operation. Okay. Flowgorithm arithmetic operators are evaluated from left to right, assuming they have the same level of precedence. Having the same level of precedence, like the multiplication and the division, which is evaluated first Whatever appears from left to right, this is correct. Another operators that have the same level of precedence is addition and subtraction, plus and minus. Okay, whatever is evaluated first is whoever appears first from left to right, and this is true. So this is basically true. Given the equation a to the power a times x to the power of 3 plus 7, which of the following, if any, are correct? Okay, Flowgorithm statements for the equation. Now if you looked at the first one, okay, the first one is completely correct. A times x times x times x plus 7, that's fine. Okay, if you looked at 2, so the first one is correct. The next one, this is not right. This is not right. This is saying that basically if you translated this mathematically, then this would be a times x to the power of 2 times between parentheses x plus 7. So this is not correct. Okay, you are trying to guarantee that this addition happens first, and this is not correct. Always the multiplication will happen first in this case. All right, the addition comes next, right? So 2 is correct, is wrong. If you go to the third one here, this is a times x between parentheses is acceptable, no worries. But when you go to the end, you will see the same wrong parentheses like the one before. So this is not really true, okay? Because you're still trying to evaluate the addition part first, and this is not correct. Okay, so 3 is wrong. Go to 4. He's saying a times x between parentheses, and that's fine. All of them are multiplication anyway, so it's not gonna make any difference. And that's it. Okay, so 4 is correct, like exactly like I or 1. All right, and let's go to 5. Now you have a times x, and this is also correct. Okay, now go to 6. You are trying to evaluate the addition with these guys first, and this is not correct. So you have I, which is 1 and 4 and 5. 1 and 4 and 5. C. Alright, now let's go to 17. Okay. Alright, so let's take the deepest parentheses and evaluate it like this. Alright, and let's say 9 times 3, this is going to give you 27, over 3, this is going to give you 9, plus 3, this is going to give you 12, times 9 times 3, this is going to give you 324. Right? Now, what is the output of the following problem? We have x, y, z as integers. X is 5 and y is 2. Z is x over y. Okay, this makes z, you would think that z will be 25, but the thing is z is an integer, so the fraction part is going to be truncated, so only 2 is going to be stored inside of z. Okay, so now you're going to say x over y. The thing is, when you try to divide like this, it's going to give you 2.5. Okay, the first condition here is going to give you 2.5 because we are not storing the result of the division anywhere. Okay, you are trying to divide 5 by 2. You're not storing the result inside a variable that only accepts integers. You're just evaluating the result. So the evaluation of 5 over 2, regardless of whatever storage this is going to be inserted into, this is going to give you the actual division result. So 5 by 2 or 5 over 2, this is going to give you 20 or 2.5, right? This is going to give you 2.5 because we are not storing this at any variable. We are just in open air. We're just in open air trying to divide 5 over 2. That's it. That's what's going on. So this is going to give you the condition is truthy. So this is the first output. When you go to the second if, remember that z was actually a storage that we have open in memory, and we have said that z is going to be integer. We have clearly specified this from the start. So basically, when you are trying to divide x over y inside of z, the division result is going to be 2.5. But when 2.5 is going to be stored inside of z, is going to refuse the fractional part because z is opened as an integer. So z is going to truncate the fractional part from this 2.5 result of the division. That's why z is going to store 2. So basically 2 is not equal to 2.5, so it's going to give you condition is falsy. Okay, try this program in Flowgorithm and you will understand what I'm talking about. Alright? The last question, what is the output of the following program? Alright, now because I've heard so many complaints about this program, let's just trace it down. Alright, first of all, I'm going to run it in front of you. Alright, this is the counter. I'm going to declare it. And we're going to choose our for loop from 1 to 10. The step of 2. Alright, and output x. Oops. Alright, now run. It's gonna give you 11. How did this happen? Now, pay close attention. Right, I'm just gonna take a screenshot of this, and I'm going here. Let's just delete this page. How can I delete this page? Okay, let's just add a new image here. No, not this guy. Alright. Okay. Just add a new workspace. This whiteboard program was really good before the update. I don't know why did they update it like this. Anyways, now let's say, remember that this if block is written like this. We have x from 1 to 10 with a step of 2. Okay, so basically we have 1, 3, 5, 7, and finally we're gonna have 9. Remember that this is our end value. Alright, so basically these are, and this is the start variable, the start value. So this is actually what we get inside this range of numbers from 1 to 10. Okay, so we're gonna step by 2, and step by 2. Okay, so let's take it one by one. This is the head of your for loop condition, and remember something, there is always a condition that's happening. Now let's try this. This is the output of x, and this is the end, and this is basically what is happening. Alright, so let's say that the first iteration, this is the memory here, and this is x. The first iteration, x is going to be 1. So I'm entering the loop, and there is x equal 1 in my hands. Okay, there is nothing really happening in the body of the loop, so I'm going back to the head of the loop. What happens when you go back is that you increment with the step that you have specified in the condition, and now x after you increment is 2. Okay, after you increment, there's a small condition that is happening inside the head of the for loop that you can't really see with your eyes, but it is implemented like this. This is how the for loop is designed. After you increment, the second step that you're gonna do is you will say, is x less than or equal the end value that we have set, which is in this case 10. X is now, when we increment, the x is gonna be 3. I'm really sorry for this. So x is now 3. If x is less than or equal to 10, then we are going to enter the loop for a second time, for the second iteration. And now, since this is correct, yes, 3 is less than or equal to 10. That's true. If this is true, then enter the loop with a new iteration. So this is the second iteration where we are entering the loop with an x of 3 in our hands. So we're going to enter the loop. Nothing really is going inside of the loop, so we're going to go back to the header. Alright, so I'm going to back to the header. First thing I'm going to do is increment. So x is now 5. Alright, now after you increment, you're going to check the condition. Is x now, which is 5, is less than or equal to the end value, which is 10? Yes, this is true, sir. Then you will enter the loop for a new iteration with x equaling to 5 in your hands. Nothing really is going on in the loop, so you're going to the header. Increment the loop. Now x is equal to 7. Okay, and there's a check is going to happen here. Is x is less than or equal to 10? Yes, x is less than or equal to 10. This is true. Enter the loop with a new iteration, right, where x now is equal to 7, and nothing really is going on so far. So I'm just going back to my head of the loop. The program is actually stuck in the for loop body until this condition turns out to be false. Then it's going to go out of the loop and execute whatever is beneath the for loop. Okay, so now going back to the head of the loop, and I'm going to increment for the last time, and x is going to be 9. Not really the last time, but let's see. Now we're going to see the condition. Is x, before I enter the loop, is x is less than or equal to 10? Yes, x is 9, which is less than or equal to 10. Then this is true, sir. Enter the loop for I believe a 4th iteration, all right, or a 5th iteration. So we are going to enter the loop with an x that is equal to 9, all right. Nothing really is going on. I'm going back to the head of the loop. Now increment the x value with a step of 2. Okay, now x is equal to 11, right? Now check, does x, which is now 11, is it really less than or equal to 10? You're gonna find that this condition, x is now 11. Remember this. This condition is going to be false because x is now isn't less or equal to 10. So basically, I'm going to head out of the loop and I'm going to execute. The loop had finished, okay? But remember, the loop had finished, but the counter, which was x, the final or the last value that was stored in x was 11. So I'm going to execute the next block here, which is outputting x to the screen. And remember, x, we have ended x with 11, so this is the value that's going to be printed. Okay, that's really important, guys. All right, I hope this is clear.